Here's a problem from 12.6 that deals with the probability of at least one event occurring. So this problem states a cooler contains 9 cans of soda. Okay, so that's 9 cans total. Of those, 4 are colas, 4 are orange, and 1 is cherry. And then 2 cans will be selected at random without replacement. Find the probability that at least 1 can is a cola. So to determine the probability that at least one event occurs, we use a formula that says we can take 1 minus the probability that the event does not occur. So in this context, that would be the probability that at least 1 can is a cola is equal to 1 minus the probability that neither of the 2 cans is a cola. Okay. So the probability that neither can is a cola, we're going to focus on that first, and then we'll subtract it from 1. But the way I would find that would be the probability that the first can that we select is not a cola, and we'll multiply that. This is an AND problem at this point. The probability of this first event, and it's a compound event with the first can being drawn and the second one being, well, I'll say drawn, selected. So it is a compound probability, or a probability of compound events, which we multiply the probability of those 2 events occurring. So the first one would be the probability that the first can is not a cola, and we'll do the second thing, that the second can we select would not be a cola, but we were given information that we want to consider this without replacement. Okay, so the probability, let's work on this, the probability that the first can that we select is not a cola, so the way that that would become a success would be, okay, we can't include the 4 that are colas, but there are 4 orange and 1 cherry that would not be colas out of a total of 9 sodas. So the probability the first can is not a cola would be the 4 orange plus the 1 cherry are not colas, just 5, out of the total cans of soda, which is 9. And then we want to make sure that we don't replace that soda. So when we don't put it back into what we consider for the probability of the next event, then the probability the second can is not a cola would be, we consider that the first one that was selected, that it was a success and it was not a cola. So we've taken out one of our sodas that is not a cola. So out of this 4, we've taken 1 away. So now we not out of 4, out of this 5, out of the 4 orange and 1 cherry, which was a total of 5, we've taken 1 of those away, which leaves me with 4 sodas that are not colas out of now a total of 8 since we took that 1 away. We can reduce that. 5/9 times 4/8 would be 5/9 times 1/2, or 5/18. Now remember that the goal of this was, once we found the probability that neither can is a cola, we're going to subtract that from 1 so that we can find out what the probability is that at least 1 can is a cola. So 1 minus the 5/18 that we just found, which would be 18/18 minus 5/18 with the least common denominator. And then as I subtract, I'd end up with 13/18. So the probability that at least 1 can is a cola when 2 cans are selected at random without replacement would be 13/18.